Hello, students. Okay, so I would like to go over the three problems that you were assigned yesterday, and all of them have to do with the second derivative test. So, in this first problem, it says you're given a function, and given a function f that is f of -1 is equal to 1. So that means you know this point, -1, 1. At each point xy on the graph of f, the slope is given by this. So this is the first derivative, and this is what the expression that the first derivative is equal to. Which of the following statements are true? So as I read through the statements, I notice that they have a relative minimum, relative maximum, relative minimum or maximum. So they're talking about relative extrema here. So if they're talking about relative extrema, then that means that we have to think about either the first derivative or the second derivative test. Those are the tests that are used for relative extrema. Okay, so for both of them, if you know both of them look for critical numbers, and they want to find out where is the first derivative equal to 0. Now, I have a point. I don't know the actual function, so I can't find, I can't solve for x where it's equal to 0, but I can put this value in, this point in for x and y, and find out what the first derivative is at that point. So I'm going to find out dy dx evaluated at -1, 1. And when I put -1 in for x, I will have that minus -1 times y, which is 1, plus 1 being squared minus 1. Okay, so that's the first derivative evaluated at this point. And when you work it all out, you should get goodbye, and that's +1, and that's -1, so you should get 0. And that means that f prime of -1 is equal to 0, which means that's a critical number. So this is a critical number, or a critical point, I should say. Okay, so now if I were to do the first derivative test, generally we would probably do some sort of number line, and we would test the derivative, the first derivative, to the right of -1 and to the left of x equal to -1. The problem is our first derivative is in terms of both x and y, and I don't know all the points that are on my f of x graph, so I can't really test the points to the right and left of x equal to -1. So then let's see what I can do with the second derivative test. The second derivative test says I need my first derivative at this point right here. I need an x coordinate where the first derivative is 0, so I've got that. So now I want to see at that same critical number, what is the second derivative? So I need to go find the second derivative. I can do the second derivative by taking the derivative of my first derivative. So let's figure that out. And so this is going to be -2x minus, and then we'd have to do product rule, so it's going to be 1 times y plus x times dy dx, doing implicit differentiation, plus 2y dy dx, and that's going to be 0. And so when I substitute in my values, I'm going to have -2 times -1 minus, in parentheses, 1 times 1 plus -1 times dy dx at this point is going to be 0, plus 2 times 1 times, again, this is going to be 0. So that means goodbye, goodbye. Those are not going to matter. This is going to be 2 minus 1 is equal to +1. Okay, so now what do I know? I know that at f prime of -1, that is equal to 0. And I know that f double prime of -1 is equal to 1, which means that it has a slope of 0 at this point, actually this point right here, and it's concave up, like so. And so if it's concave up, that means that we have a local minimum, which is not this. It has neither. So I think the only solution that we have is A. All right, and so that was applying the second derivative test. All right, number 2. It says, let f be a twice differentiable function. Which of the following statements are individually sufficient to conclude that x equal to 2 is the location of the absolute maximum of f on this interval? All right, first, before I continue, twice differentiable. What does that mean? If the function is twice differentiable, that means that f of x must be continuous on this interval, -5 to 5. That also means that f prime of x must be continuous. It must exist on this interval, -5 to 5, which means there cannot be any derivatives where your x value does not exist. Okay, you don't have any vertical tangents, or you don't have any abrupt changes in the slopes. Okay, you have a nice smooth curve. That's what it means for it to be twice differentiable. Okay, so the first one, f prime of 2 is equal to 0. That means we've got a critical number. That just means that the slope is 0. So that doesn't necessarily mean that we have an absolute maximum. Okay, x equal to 2 is the only critical point of f on the interval. So if it's the only critical point, and this is a twice differentiable function, what does that mean? That means f prime of 2 is equal to 0. And so you've got something where the slope is 0, and then on this interval, f double prime of 2 is less than 0, which means that its concavity is going to be, it's going to be concave down, and this is going to be a negative value. So since this is the only critical point on this interval, that means that there's going to be only one really turning point in this interval, and so it's got to go up and then down, and so therefore this has got to be an absolute maximum. So 2 would work. Let's see 3. Again, x equal to 2 is the only critical point, so that means that f prime of 2 is equal to 0. I can hear it. Can you help her, baby? And if I look at a number line, let's see, here's -5, here is 2, here is 5. And so this is the lowest y value, this is the second lowest y value, and this is the highest y value. And if the slope is going to be 0 right here, you've got this situation, like so. And so that means, again, that this is going to be an absolute maximum. All right, and then the last one. Again, this is a twice differentiable function, so that means that it is continuous and there are no points where it has a vertical tangent and abrupt changes in slope. Okay? And so you have a table that shows the first derivative and the second derivative. It says, which of the following statements are true? And so I look at each of the x values that they're talking about, and they're looking at x equal to 1 and at x equal to 4. So what's going on at these x values? Let's see. At x equal to 1, you have f prime of 1 is equal to 0, and f double prime of 1 is equal to -2. So that means it has a slope of 0 and that it's concave down. Okay? And at 4, f prime of 4 is equal to 0, and f double prime of 4 is equal to 1.2. So that means it has a slope of 0, and since this is positive, it is concave up. All right. So which of the following statements are true? F has neither a minimum or maximum. Well, we can see that it does have a relative minimum maximum here. So And then let's see, it has f has a relative maximum at 1. So that would agree with what we found here. And f has a relative maximum at this, and this is supposed to be a relative minimum. So it would not agree with that one. So the answer would be 2. And that's it. Thank you.